Hello my dear friends and students, this is Sir Palmath and welcome to my video channel. In this video, we are talking about the addition and subtraction of radicals. This is the part of your grade 9 lesson. Let us start with our learning objectives for today's lesson. Here are our learning objectives. First, you will be going to determine similar radicals. And second, you will be going to simplify algebraic expressions that containing the sums and difference of radical expressions. Okay, so let us start with our simple topic, which we are talking about similar radicands. What is similar radicands? Radical expressions with the same indices and radicands are called similar radicals. Meaning to say, if sum of radical expression in every terms has the same indices, so indices refers to the nth order or the principal root, like the square root, the cube root, the fourth root, fifth root, sixth root, up to the 10th root, and so on and so forth until the higher order radical principal roots. And just radicands are those monomials or terms inside the radicands. So, if two or more radical expression with the same indices and radicands, so they are called similar radicands. So here are some of their examples of the pair of similar radicals, like 12 times square root of 5 and 9 times square root of 5. So since we have the same radical terms, which is square root of 5, so since square root of 5 has a common factor of these two terms, we have 3 times square root of 3x and 4 times the square root of 3x, because we have the same radical terms, which is square root of 3x. And of course, we have 23 times the cube root of 10 and 14 times the cube root of 10, because they are similar radicals, because we have the common factor, which is the cube root of 10. So we have the common factor is cube root of 10, which is said to be similar radicands. Such radicals are added or subtracted in the same way that the monomials are added or subtracted. This procedure is much like combining similar terms. So my dear friends and students, so you know how to combine similar terms. You learned in your grade 7 lesson. So it's very easy. So in simplifying the radical expression, we use the another property rule, which is the what we call the distributive property rule. So distributive property rule in the form of A times the quantity of the binomial B plus C, which is equal to AB plus AC, to combine similar radicals. Okay, so we use the distributive property rule in the form of this in order to solve for the sum and differences of the radical expressions. Consider the given example on how to simplify 12 times the square root of 5 plus 9 times the square root of 5. So on the process, we have the following. So we follow that we have the given 12 times square root of 5 plus 9 times square root of 5. So we get the common factor, which is square root of 5. So applying the distributive property of multiplication all over the terms, so we have square root of 5 multiplied by the quantity of 12 plus 9. So in this process, we use the applying distributive property. And then we simplify inside the parentheses, as we have to apply to use the PEMDAS rule. So we have 12 plus 9, so we get 21. And after that, you will be going to simplify this product. So by the use of commutative property of multiplication, we have the result, which is 21 times the square root of 5. However, you can combine similar radicals immediately as you would with 12x plus 9x to get 21x. So therefore, 12 times square root of 5 plus 9 times square root of 5 is equal to 21 times square root of 5. So can you imagine that in this radical term, you have to let the value of one variable, which is let x. Instead of you're using 12 times square root of 5 plus 9 times square root of 5, we have 12x plus 9x, so we get 21x, and replace it from the value of x, which is 21 times square root of 5. So that is very easy. So, to simplify radical expressions through the process of addition and subtraction, I will present to you some of their illustrative examples on how we'll be going to simplify using the addition and subtraction of radicals. Let us begin with our first illustrative example, number 1. So how will you going to simplify 6 times the square root of 11 plus 2 times the square root of 11 minus 3 times square root of 11? To simplify the given radical expression, here is our solution. So first things first, you will be going to simplify the given radical expression, presenting the given. And after that, you will be going to applying the distributive property. So since in every coefficient of the given radical terms, so we get 6 times square root of 11 becomes 6, 2 times square root of 11, it becomes 2, and negative 3 times square root of 11 becomes negative 3. So this is the process of applying distributive property. After that, you will be going to combine similar terms. So inside the parentheses, we have 6 plus 2, it becomes 8, 8 minus 3, it becomes 5. That is 5 times the square root of 11. And after that, you will be going to simplify the product by eliminating the parentheses. So it becomes 5 times the square root of 11. And that is our answer. Let us proceed to the next example. Illustrative example number 2. How will you be going to simplify the given radical expression 23 times the cube root of 10 minus 14 times the cube root of 10 plus cube root of 10? To solve for this radical expression, here is our solution. To solve for the given radical expression like this, so we have the given first, and then you will be going to get all of these coefficient of every radical terms. So by using the applying distributive property law. So we have the first term, which is 23, and then we have negative 14, and we have positive 1. Why positive 1? Because in the given radical term, 3 or the cube root of 10, so we understood that if there is no coefficient appearing in this radical term, we understood that the numerical coefficient, which is 1. So that is 23 minus 14 plus 1 times the cube root of 10. After that, we're going to combine similar terms. So that is 23 minus 14 plus 1 times the cube root of 10, it becomes 10. Okay? So 10 times the cube root of 10. And after that, you will be going to simplify this product. So we have eliminating the parentheses, it becomes 10 times the cube root of 10. And that is our final answer. Let us proceed to another illustrative example number 3. How will you simplify 3 times the square root of 2x plus 4 times the square root of 2x minus square root of 2x? To simplify this given radical expression, here is our solution. Okay, to simplify this given radical expression, so first we have the given, and after that, this is the same manner to do by applying the distributive property. So we get the coefficient of every radical terms. So we have 3, and then the next term, which is positive 4, and this one we have minus sign, and we understood that the coefficient of this is 1. So if there is no numerical coefficient appearing in a radical term, we understood that this term is negative 1. And then we have 3 plus 4 minus 1 times the square root of 2x. The next step to do is to combine similar terms. So which is 6 times the quantity of square root of 2x. And then we'll be going to simplify the product by eliminating the parentheses. So it becomes 6 times the square root of 2x. And that is our answer. So let us proceed to the next illustrative example number 4. How will you simplify 2 times the square root of 2 plus 4m square root of 5 minus m times the square root of 3? To simplify the given expression, here is our solution. So here is our solution. To simplify this, 2m times square root of 2 plus 4m times square root of 5 minus m times the square root of 3. Look at this at every term of the given radical expression. So in this case, we have the different radicands. So we have square root of 2, square root of 5, and square root of 3. So in this case, the given radical expression 2m times the square root of 2 plus 4m times the square root of 5 minus m times the square root of 3 cannot be simplified further. Why? Because the radicands are not similar. So since we have square root of 2, square root of 5, and square root of 3 are not similar, but they are different. There are no common factors and each radicands are in a simplest form. So in this case, to simplify the given expression, the answer is still the same. So my dear friends and students, let us proceed to the next illustrative example. Illustrative example number 5. So the similar to similar. So you will be going to simplify each pair of radical expressions to make them similar radicals. Let us start with letter A, the square root of 45x and the square root of 20x. Letter B, the square root of 32m squared and 2m times the square root of 8. And letter C, 4a times the square root of 12b and 5 times the square root of 75a squared v. To solve this, to convert this, the pair of radicals, here is our solution. Okay, to convert this, a pair of radicals to make similar fraction or similar radicals, so we have the square root of 45x and square root of 20x. The first step to do is to factor out each radicands with a perfect square factor. So this is the process in order to us to get the perfect square, it has at least one factor. So we get the factorization form of 45x and 20x. So we have the 45x, it becomes 9 times the square, we have 9 times 5x. At least we have only one perfect square factor. From 20x, we have 4 times 5x. At least we have a perfect square factor which is 4. The next step to do is to simplify the perfect square to make a similar radical of square root of 5x. So we notice that in every pair of radicals, it has a common factor of 5x inside of each of their radicand. So we have the result, so which is by eliminating the perfect square, so we get the square root of 9, which is 3, and square root of 4, it becomes 2. So therefore, this pair of radicals, 3 times square root of 5x and 2 times the square root of 5x are said to be similar. So let's proceed to the next example, letter B. Okay, how about the square root of 32m squared and 2n times the square root of 8? So the first step to do is to factor out each of the radicands with a perfect square factor. And this is the same procedure from the previous example, letter A. So in this process, we have the square root of 32m squared and 2m times the square root of 8, it becomes, so we factor out 32m squared, so it becomes 16m squared and 2. So first things first, we have to factor first the numerical coefficient, which is 32. So we get 32, it becomes 16 and 2. And we have the literal coefficient, which is m squared, is also a perfect square. So 16m squared is at least a perfect square factor, monomial. And of course, from 2m, square root of 8, so we factor out square root of 8. So it becomes 4 times 2. So at least we have a perfect square factor, which is 4. The next step to do is to simplify the perfect square to make a similar radical, which is square root of 2. So it becomes, so we simplify the square root of m squared, it becomes 4m. And we simplify the square root of 4, it becomes 2. So we have 4m times the square root of 2 and 2m times 2 times square root of 2. The next process would be simplify the product, the second radical term, which is 2m times 2 times square root of 2. So we simplify 2m times 2, it becomes 4m square root of 2. So 4m square root of 2 and 4m square root of 2 are said to be similar radicals because it has a common factor of square root of 2. Let us proceed to the next example, letter C. How about 4a times the square root of 12b and 5 times the square root of 75a squared b? To simplify each of the radicals to make similar, here is our solution. So the first step to do is to factor out each radicals with a perfect square factor. So this is always the same procedure from the previous two examples. So we have 4a square root of 12b and 5 square root of 75a squared b. So it becomes 4a times, we factor first 12b. So let us first factor the numerical coefficient. So at least 4 times 3. So at least 4 is a perfect square. And we copy the variable which is b. So it becomes 4 times 3b. The second one is 75a squared b. So we factor out 75, it becomes 25 times 3. So 75, so 25 times 3, it becomes 75. At least 25 is a perfect square. And we copy the perfect square term, which is a squared. And then we have the remaining, which is 3 times b. Okay? So we proceed to the next step. We will be going to simplify the perfect square to make similar, which is the square root of 3b. So we found out the result given. We get the square root of 4, which is 2, and square root of 25a squared, which is 5a. And then we'll have to simplify both of each two radicals, their products. So it becomes 4a times 2, it becomes 8a, and 5 times 5a, which is 25a times the square root of 3b. And that is our final answer. So let us proceed to the next illustrative example. Okay, illustrative example number 6. So now, how will you simplify the given radical expression with a different radicals, which is 10 times the square root of 50 plus 7 times the square root of 72 and 5 times the square root of 98. To solve this given radical expression, to simplify, here is our solution. Okay, so to solve this, to simplify the given radical expression with a different radicals, which is dissimilar. Okay, we have square root of 50, square root of 72, and square root of 98. So the first process to do, we have the given, and then you will be going to factor out each of the radicands with a perfect square factor. So we have to factor out first the square root of 50, so it becomes 25 times 2. At least 25 is a perfect square. And then we factor out 72, so we get 36 times 2. At least we have a perfect square factor, which is 36. And square root of 98, so the factorization form is 49 times 2. At least we have a perfect square of 49. The next step to do is to express every perfect squares into exponential form or exponential squares. So that the value of 25, it becomes 5 squared. The value of 36, it becomes 6 squared. And 49, which is 7 squared. So that is, we have the exponent form of each three perfect squares, 25, 36, and 49. The next step to do is to simplify a perfect square to make a similar radical of square root of 2. So we get the square root of 5 squared, or each short square root of 25, it becomes 5. The square root of 6 squared, it becomes 6. And the square root of 7 squared, it becomes 7. Okay? So we have a similar radical, which is square root of 2. The next step to do is to simplify each product of every terms. So becomes 10 times 5, it becomes 50. 7 times 6, it becomes 42. And 5 times 7, it becomes 35. And then we are going to apply the distributive property process to combine these constant terms. So 50, 42, and negative 35. And then we get the common factor, which is square root of 2. So we get 50 plus 42 is 92 minus 35. It becomes 57 square root of 2. And that is our final answer. So my dear friends and students, let us proceed to the next illustrative example. Illustrative example number 7. So now, how will you simplifying the combining like terms? Given 7a times the square root of 8b plus 4a times the square root of 12b minus 2a times the square root of 18b and plus 5a times the square root of 3b. To solve this given radical expression by simplifying combining like terms, here is our solution. Okay, so the first step to do is to simplifying combining like terms. We have the given. The next step to do is to factor out each of the radicands with a perfect square factor. This is always the first step to do, same as with a previous example number 6. So we factor out square root of 8b, so it becomes 4 times 2, and copy the variable which is b. So at least we have the perfect square which is 4. Next, to factor out 12b, so we get the factor form of 12 which is 4 times 3. At least we have a perfect square which is 4, and copy the variable which is b. Then we factor out 18b, so it becomes 9 times 2, and b we have to copy the variable. And then the square root of 3b, so it doesn't have a factor since 3 is a prime number, so we copy the last term. So it becomes 5a times square root of 3b. The next step to do is to extracting the roots each term. So by simplifying the perfect squares, so the square root of 4, it becomes 2, the square root of 4 is also 2, and square root of 9, it becomes 3. So we have 7a times 2 times the square root of 2b, 4a times 2 times the square root of 3b, minus 2a times 3 times square root of 2b, and the last term, copy the last term, 5a times square root of 3b. The next step to do is to simplify the product of each term. So we have 7a times 2, it becomes 14a, 4a times 2, it becomes 8a, 2a times 3, it becomes negative 6a, so don't forget to bring along with the sign, and copy 5a times the square root of 3b. Okay, we notice that we have the red mark and the green mark. So the red mark, that shows it has a coefficient of square root of 2b. So we have the similar terms. Of course, the green ones, we have the square root of 3b. They are similar to 8a and 5a. So by doing this, we are combining similar terms, each of their different radical terms, using the distributive property. So see 14a minus 16a, it becomes like this. So that is the outcome using distributive property. Same with the green ones, 8a and 5a, so 8a plus 5a times the square root of 3b. And that is 14a minus 6a, it becomes 8a square root of 2b, and 8a plus 5a square root of 3b, it becomes 13a square root of 3b. And that is our final answer. So the final answer, it has containing two terms. It has a radical term of square root of 2b and the square root of 3b. Let us proceed to our last illustrative example number 8. Okay, so this time, how about the given radical expression? We have a different indices. So we'll be going to simplify, then combine the given radical expression, the square root of 12 plus the fourth root of 144 minus the sixth root of 27. So my dear friends and students, to solve this given radical expression, to simplify and combine these radical terms, here is our solution. To simplify the given radical expression with a different indices, we have the given first. And then, the next step to do is to change into exponential form. So the first term, so we all know that we are going to factor out first the value of the radicand, which is 12. So the factor of 12 is 4 times 3. At least we have a perfect square, which is 4. Next term, you will be going to convert the radical form 4 times square root of 144 into exponential form. We all know that inside the radicand, the 144 has an exponent of 1. And we have, since the nth root is 4. So we convert that 144 raised to the power of 1 over 4. Okay? Next, we convert also the next term, which is 6 root of 27 into exponential form. So since we all know that inside the radicand is 27, has an exponent of 1 also, and then the nth root, which is 6 root, so under the denominator. So it becomes 27 raised to the 1/6 exponent. And that is our step-by-step process. Okay, the next step to do is to going to express the bases 144 and 27 into exponential form. So did you know that 144 is a perfect square? So 144, which is expressed into exponential form into base 12. So it becomes 12 raised to the power of 2. And then raised to the power 1/4 minus. We also, 27 is also a perfect cube number. Since we express as base 3. So it becomes 3 cubed. And then raised to the power of 1/6. The next step to do is to applying the product rule of exponents. Now, so by product rule of exponents, so we get the exponent of 2, which is multiplied by the outer exponent, which is 1/4. So this is a power of a power. So it becomes 2 times 1/4, it becomes 2 over 4. Same with 3 cubed times raised to the power of 1/6. So applying the product rule, which is 3 over 6. The next step to do is you will be going to reduce these exponents into lowest term. So we all know that 2 over 4 has a greatest common factor of 2. So divide each the numerator and the denominator by the greatest common factor. So 2 divided by 2, it becomes 1. And 4 divided by 2, it becomes 2. So it becomes 1/2. Same with 3 over 6. We can be also reduced into lowest term, which has a greatest common factor of 3. So 3 divided by the GCF of 3, it becomes 1. 6 divided by 3 of GCF, which is 2. So we have 1/2 exponent. So the last two terms have the same exponent. So we'll be going to convert back into radical form. Since we all know that 1 is the numerator and the denominator is 2, so it has an order of 2, which is square. So becomes square root of 12. Same with 3 to raise to the power 1/2, it becomes square root of 3. The next process to do is to convert it into products. So we all know that square root of 12 as the same on the first term, it becomes 4 times square root of 3. Okay, 4 times 3 rather. So minus square root of 3. The next process is to extracting the roots by simplifying the perfect square. The square root of the perfect square of 4, which is 2, we have also the same as also 2. Then combine it using the distributive property. So 2 plus 2 minus 1 times square root of 3. We have 2 plus 2, it becomes 4 minus 1, which is 3 square root of 3. And that is our final answer. So these are some of their illustrative examples on how you will be going to translate radicals into similar form and proceeding to simplify using the addition and subtraction of radicals. And that is our lesson for today. So my dear friends and students, so thank you very much for watching and listening. To God be all the glory. God bless us all. Hello my dear friends and students. This is Sir Palmath and welcome to my video channel. In this video, we are talking about the addition and subtraction of radicals. This is the part of your grade 9 lesson. Let us start with our learning objectives for today's lesson. Here are our learning objectives. First, you will be going to determine similar radicals. And second, you will be going to simplify algebraic expressions that containing the sums and difference of radical expressions. Okay, so let us start with our simple topic, which we are talking about similar radicands. What is similar radicands?